All right, hello, Algebra 2. We are going to do our 6.5 notes now. And this is solving. As always, I'm going to go fast because you can stop and rewind. Solving square root and other radicals. Okay, solving square root and other radicals. So, just some vocabulary here. The radical symbol is this little check mark and then line. The index is 3. That's that little number right here. And what's underneath the radical symbol is the radicand. We're going to use reciprocals here. So two numbers are reciprocals if their product is 1. So that would be 1/3 for 3. 3 times 1 over 3 is certainly 1. And for -7/4, that would be -4 over 7. -7/4 times -4 over 7 certainly multiplies to +1. So those are reciprocals. Okay, so some steps for solving radical equations. The first thing you're going to want to do is isolate the radical, or if there's two radicals, you want a radical on each side. You want to put a radical on each side. Okay, radical on each side. All right, so the next thing you're going to do, so here's question number 1. Well, I've got the radicals isolated. That just means there's nothing around it, like there's nothing added to it, subtracted, nothing multiplied. I've got it really clean here. So now I want to, this is a square root, so I want to square both sides. So raise both sides by the index. All right, so this index is 2, which, if you were to, a square root is like a 1/2, so we multiplied by its reciprocal 2. But, I think students pretty much get that you negate a square root by squaring. Okay, so this just plays, knockout, and you get x minus 3 equals 1, and x is 4. Okay, so solve for x is the third step. And the fourth step here is to check for extra solutions, and those are called extraneous. This just means extra solutions. So this is not an optional check. This is a must check. When you are, this is for if you raise to an even power. If you raise to an even power. All right, if you raise to an odd power, you don't have to do it. But if you raise to an even power, extra solutions can pop into the problem. I know that's kind of confusing, but they do. So when you square, you have to check. So in the check here, I'm just going to go, is 4 minus 3 equal to 1 under the radical? Is root 1 equal to 1? 1 equals to 1, yes. Make sure you don't give the answer as 1. This is the answer, but it checked. All right. So, the reason that happens, just probably too much information, but let's say I tell you without a doubt that x is equal to 6. That's facts. Okay, x is 6. Done. This is the original equation, a super simple one. It looks like an answer. But let's say I'm calling this my original equation, and that's a truth. So let's say I'm bored and I decide to, I want to take my original equation. I want to square it. Okay, I want to square it. All right, well, that was fun. And let's say I'm bored and I think, well, maybe I'll square root it. Well, when you put a square root in the problem, in come that plus or minus. So now all of a sudden I've got x equal to 6 and x equal to -6. Okay, and that's correct for this part, but we started the problem at x equal to 6. So when I go to sub back into the original, you have to plug 6 equals 6 in. When I plug -6 in, that doesn't work for this particular. So an extra solution popped up when I squared this original equation. All right, so you got to be careful when you're raising to an even power that you don't submit an extra solution. All right, so that checked. All right, so this one, this is one where I have, so be sure you check for extraneous solutions. That just means extra solutions. So here I got a radical on each side, so we're good to go. I'm going to square both sides. Okay, so make sure you square the 4. Square root of x squared is just x. And we square this side, and you just get x minus 5. So minus x, that's 15x, equals this negative 5. Divide by 15, divide by 15, x is equal to negative 1 over 3. Okay, check your solution. It's not an option. Okay, so the minute I go to check, here's my check here. Let's do my check. Okay, so the minute I go 4 times negative 1 over 3, I have an issue. That's an imaginary number. So immediately we're out. So negative 1 over 3 minus 5. So what do they say on TikTok? Immediately no. That's out. So this is out. This problem has no solution. Okay, no solution there. Okay, this one is a cubed root. So I'm going to raise it to the 3rd power. Okay, that will counteract. Okay, so, again, that's a 3. And so as an exponent, x is to the 1/3, right? So as an exponent, this index is 1/3. So when I go to negate it, I want to use the reciprocal, which is actually 3. Those don't look like reciprocals right here because they both look like they're 3. But this, as an exponent, is 1 over 3. So we do the reciprocal, which is 3. Okay, so this is x plus 4 equals 3x minus 6. Okay, so if I just do minus 3x, and plus 6 and plus 6, I end up with minus 2x, Well, I should have done that the other way, huh? I should have done minus 4. That was silly. Okay, so let's do minus 4. Okay, so that cancels. I get negative 2x equals negative 10, and x is equal to 5. Okay, so this is if you raise to an even power. I raised this to an odd power, so I don't have to check this one. The checking is not part of the process. So you could always check just because it feels good to see a good result, but it's not mandatory on letter C. Not mandatory on letter C. Okay? All right, so onward and upward to the D and E are a little more D and E a little more difficult. Okay, so isolate the radical. So I want I just want this radical by itself. So I'm going to move this over. That's called isolating the radical. Okay, so when I isolate the radical there, it looks like this. All right, and so I'm going to square both sides. Okay, so that's 3x minus 5. Yay! And then on the left side, most students want to write down x squared plus 25, okay, or x squared minus 25, because that's easier, and we kind of sometimes like the easy path, but it's not right. Okay, so x minus 5 has to be x minus 5, x minus 5. You have to FOIL this. I know. You have to FOIL this. Okay, so this is x squared minus 5x minus 5x plus 25 equals 3x minus 5. X squared minus 10x plus 25. Okay, so this is a quadratic. I'm going to set it equal to 0, so minus 3x plus 5. X squared minus 13x plus 30. Okay, so you set quadratics equal to 0. So lots of good stuff here. Isolate, square both sides, FOIL, set to 0. And now I'm going to factor and solve. X minus 10, x minus 30. So two things: when multiply to 30, when add to 13, that's 10 and 3, and the signs are negative because that sign is negative, the sign of the middle term. So x equal to 10, x equal to 3. Okay? So I squared both sides. Got to check. It's mandatory. X equal to 10. Let's check it, and we check into the original. Is 10 equal to 5 plus, just throw a 10 in there, 30 minus 5? Is 10 equal to 5 plus root 25? Is 10 equal to 5 plus 5? You bet. So 10 is golden. Next one, x equal to 3. 3 equal to 5 plus, okay, so 3 times 3 is 9. Minus 5 is 3 equal to 5 plus root 4. Is 3 equal to 5 plus 2? No way. So that's out. Okay, you got to check. It's mandatory. Have to check, and you just check up into that original. Okay, so next problem. You guys really aren't going to like me very much after this problem, but it's not me. It's math. I didn't invent it. I'm just leading you through it. Okay, so I've got two here. A radical, so I want one on both sides. So I'm going to move this one over here for plus 2 root 2x. So I just pick up that term, that negative 2 root 2x, just pick it up and plop it over here as a positive. Okay, so I can't get this pesky 1 is going to cause me grief, but I can't get rid of it. It's there to stay. So I'm going to square both sides. And this is going to be 2x plus 5. Okay, this is going to require foiling. Okay, and here we go. So 2x plus 5. Okay, so there's F, O, I, and L. So that's plus 4, and then root 2x times root 2x is root 4x squared. So still didn't get rid of the radical. So we're going to have to, guess what? Square this again. So this is 1 plus 4 root 2x. Those are like terms. They are 2 root 2x and 2 root 2x. That's a total of 4 root 2x. And then back here, this is going to simplify to 2x and multiply there. So that'll be plus 8x. All right? So I'm going to isolate the radical. So this problem has 2 cycles of squaring. I'm going to isolate the radical. So I'm going to get this all alone. So I'm going to minus 1, and I'm going to minus 8x. So minus 6x plus 4 equals 4 root 2x. Okay, square both sides again. Okay, so this is going to be foiling. Okay, when I square this side, I'm going to square the 4 for 16, and squaring the square root just breaks that 2x out. All right, let's FOIL. Minus 36x squared minus 24, that's minus 48x plus 16. Got a quadratic. This is going to be 32. Let's move that over. So I've got negative 36x squared. Oh, I'm sorry, that's positive. Yay, that's positive, my bad. Negative times a negative is a positive. So positive 36x squared minus 80x plus 16. All right, I'm going to factor a 4 out of there. 4, 9x squared minus 20x plus 4. And factor it. Okay, so this factors as 2, 2, minus, and minus. Okay, so the signs are minus, minus. That's plus, the signs are minus, minus. And I just have to work through the combination so that I get 9x and x makes 9x squared. This makes negative 18. This makes negative 2 for negative 20x. And then back there is plus 4. Okay, so 4 equal to 0. That's a scalar. We throw that out. 9x minus 2 equals 0. 9x is 2. X is 2 over 9. Okay, and then right here, we get x is equal to 2. Okay, so we need to check those. I'm going to have to do my extend the page on paper by getting a new page. So let's do that. All right, so I'm going to take this original here, and I'm going to check x equal to 2. All right, x equal to 2 is, 2 times 2 is 4 plus 5 minus 2. 2 times 2 is 4. Does that equal 1? Okay, so does root 9 minus 2 times 2 equal 1? Does 3 minus 4 equal 1? Nope. So, goodbye. And let's check 2 over 9. Okay, so back to this original 2 over 9 times x here is 4 over 9 plus 5 minus 2 times 4 over 9 equal to 1. I need a common denominator of 9. Okay, minus 2 times 2 over 3. So that's root 49 over 9 minus 4 over 3. 7 over 3 minus 4 over 3, is that equal to 1? Yes. So this one checks. Okay, so 2 over 9 checks. All right, next page. All right, so now these look a little different. You see the a rational exponent, but it's kind of the same thing, same field, just looks a little different. So I'm going to isolate. So divide by 2, divide by 2. Let me give myself some room. Okay, so let's just rewrite it. Give myself some room. Okay, divide by 2, divide by 2. Okay, so I got x plus 3 to the 2 over 3 is 4. So isolate the radical term, so that's when you have a fractional exponent. All right, now we're going to raise each side to the reciprocal power. So x plus 3, 2 over 3, we're going to raise that to 3 over 2. Okay, we're going to raise that to a 3 over 2. Okay, so if the numerator of 2 over 3 is even, then you're raising it to 3 over 2, and so this is a square root. And when you take the square root of both sides, when you put the square root into the problem, you have to do the plus or minus. So because this is a denominator, I'm going to need to use the plus or the minus here. So what does that look like? Well, first of all, these play knockout. 2/3 times 3 over 2 is x plus 3. All right, and so when I take the square root of 4, and then I'll cube that in just a minute, since I put the square root into the problem, just like the square root theorem, I've got to put plus or minus 2 there. So you got to remember that when you are always square rooting, and I know it doesn't look like a square root because it's over 2, but if you're over and even, you got to put in the plus or minus. So x plus 3 equals to 2 cubed, x plus 3 equals to negative 2 cubed, x plus 3 equals 8, so x is 5 here. Okay, and then x plus 3 equals negative 8, so x is negative 11 here. All right, so did I square both sides? No. I square rooted, so I had to do the plus and minus, but then I cubed. So if I didn't square both sides, I technically don't have to check. So that's good news. All right, couple more here. This is 4x to the 1/2 plus 5 is 32. Divide by 4, 8. Okay? So I am squaring both sides, which means I have to check. You square root both sides, plus or minus. If you square both sides, check. So x is equal to 64. Is 4 times 64 to the 1/2 minus 5 equal to 27. Okay? Is 4 times 8. The square root of 64 is 8. Minus 5 equal to 27. Is 32 minus 5 equal to 27? You bet. So this checks out. All right? Isolate x minus 2 to the 2 over 3. Plus 4, 9. Plus 4, 9. Okay? raise to the 3 over 2. All right, so I'm square rooting, plus or minus is going to come in, and then I'm cubing. So this situation, plus or minus has to come in. So those negate. Okay, so I'm going to take the square root of 9, quantity cubed. So x minus 2 is this plus or minus comes in cubed. So x minus 2 equals 3 cubed, and x minus 2 equals negative 3 cubed. So x minus 2 equals 27, x equals 29. Okay, and then on my other one, I'm going to get negative 27, and then plus 2, so negative 25. So x minus 2 equals negative 27, plus 2, x equals negative 25. All right, so I never raised to an even power. I don't have to check those. Those are both solid answers. Last one, 4x to the 3 halves plus 5, 108. Divide by 4, x to the 3 halves equals 27. Raised to the reciprocal to play knockout. Okay. And so with this one, I'm going to get, I am squaring and then cubed rooting, right? So squaring this one means I have to check. So this is x equals cubed root of 27 quantity squared. So that's just 3 squared, okay? This is not square rooting, so I don't have to do the plus or minus. So x is 9, but I do want to check it. And you can also check with your calculators if you want. Let me just get mine over here. Okay. So, you know, you could always go to your original 4 parentheses 9 to the 3 over 2 minus 5. Boom. 103. Check. So it checked out. Okay, last problem, a little word problem. It just says this formula relates the surface area A in square units of a cube to the volume V in cubic units. What's the volume of a cube with surface area 486 inches squared? So just a word problem that has a rational or a fractional exponent. So 486 is the area, the square inches area, and they want us to find the volume, so solve for V. So divide by 6, that's 81. Okay, that's 81. And so I've got V 2/3, 81. Let's go to the 3 over 2. 3 over 2, okay? So V is going to be the square root of 81 quantity cubed. So since I'm square rooting, you know, plus or minus, so this is plus or minus 9 cubed. So volume would be 9 cubed, which is 729, and inches cubed for volume. The inches are cubic. They're 3-dimensional, so you put a 3 here. And then volume is negative 9 cubed. Volume is negative 729 inches cubed. But wait a minute. That doesn't make any sense. How are we going to have capacity, which is volume, be negative? Doesn't make any sense, so you don't need that there. It doesn't make sense to the word problem. All right, long video, I know, but there you are. And good luck with solving radical equations. Your homework here is right here, okay, and this is posted in Google Classroom. And try these 10 problems, and I'm going to get the key posted there as well, okay? So check this out. I was thinking about making a video for me solving these, but I think I'm out of time. Okay, all right, bye guys.